So I guess I'll start with the legal disclaimer. It's required by the company. Our logo, our whatever we're going to, I guess, show today. There are somewhat forward-looking information and stats and performance information. Again, they have the normal caveats around that. So let's move forward. So I'll try to, since likely most of you guys have never heard about Purestorage or why we are even here at an AI conference. So I want to first start with a quick introduction of what Pure is doing and what they're targeting, and then we'll go into how we actually enabling AI out in the industry. So to talk about Pure, I have to take you about in the memory lane, go back a little bit in the time, around 12 years back or 13 years back. It's around 2012 time frame. Basically, Flash were coming in, laptops and mobiles were starting to use Flash as a storage medium. And basically, the founders of Pure decided to go all in for Flash as the enabling technology for Flash, for storage in the enterprise. That was the vision we created. We got some excitement behind it. We got some early adopters who were probably bought into our vision into the all Flash-based storage medium. We are relatively successful today. We have been gaining customers one by one. They have become promoters of our solution. Basically, go data center by data center, win the customers, and as we have gone there, they started loving our product, but more than they started loving our vision, and they've been part of our journey throughout this phase of the last decade or so. That's what led to what we consider the key metrics. If you look at net promoter scores, we are one of the highest in the industry. We have consistently been keeping 80+, which gives you an idea of how our customers are really loving Pure as a solution for storage. In other marketing terms, for Magic Quadrant, market share, we have consistently doing pretty good. And as far as a great place to work, only very recently, along with the US, even the Bangalore site now actually has got this award pretty consistently for year after year now. But in the grand scheme of things, our mission really is to provide the most advanced data storage platform. As you go into more into AI story, what are the three key? There's a compute angle, and there is an I/O. In the I/O, you look at network, and the other one you look at is storage. And these are three core infrastructure pieces. If you look at an AI infrastructure, which drives the rest of the application innovation that you guys are talking about and actually using today. The other key piece that we are very proud about, because it's all Flash-based, it has a very interesting environmental impact. It's less energy, and if you look at anybody building data centers, energy is one of the key driving decision-making factors out there. And that's actually helped us get the adoption in the market segment, including some very interesting wins even in India recently, which we can't talk about yet. Okay, and one last slide, what Pure does. We started with providing some point solutions as storage. Now we see ourselves, our vision really is as storage is the service, storage is the platform, and which is available on-prem, whether it's in cloud or whether it's hosted environment. And the key, I would say, mantras behind that is ease of management at any scale, from small to medium to extremely large, and we'll talk about some of those use cases later in this today. The other one we are really pushing hard on is to keep it simple. We follow the KISS principle, keep it simple and stupid, and that's really one of the key driving factors why adoption is so good. And the last one is the evergreen model, which in simple terms, it basically is the cloud operating model where you pay as you go. And you don't worry about any of the upgrades, any of the actual end of life cycles on the hardware or software. Once you buy into our vision, into our solution, we'll take care of you year after year. So let's dive into something much more interesting, what this audience likely is more interested in, right? So as we look at storage, and as we look at AI, right, there's a little way out there, and the world keeps changing on us every year. It's a bit cloudy, there are like hills and valleys all over the place. Now we're all dreaming up different solutions out there. My favorite solution of AI, if somebody could move to a self-driving, especially in the Bangalore traffic, if you look at it, and maybe that will get us to lane-based driving. Just to give you a context, I've been in California and US for the last 20 plus years. I recently moved here. One of the biggest challenges is the traffic here, right? But that's one of the key solutions I expect in 5 to 10 years, even in Bangalore, will solve some of these challenges we have, right? But then what is Pure doing to enable that, right? One of the 4 things we look at, right, what's going on. There's challenges in underutilized GPUs. There's inconsistent performance, depending on different workloads as the world is evolving. If you guys follow any of the NVIDIA announcements, you can see new solutions being pushed, new hardware being pushed pretty much every 1 to 1.5 years, right? The second piece, which is around scalability. As the adoption is increasing, as the algorithms are moving forward, we are seeing the scalability move in different directions and keep changing. And what we mean by metadata is there's one part about the data actually that people are feeding in that we were just hearing in the previous talk also, right? But there's also the metadata. What is the context behind that data? Who created, when? Those type of attributes you would look at. And that becomes, in the infrastructure layer, very, very interesting. We also see silos in the data centers out there, and we also see a very, very high cost of ownership. Yes, a big part of the dollars out there are, sorry, I'm talking dollars terms, but dollars or rupees, or any currency. You will see the big cost of ownership is actually moving in this solution space, or the AI solution space. And the biggest pie there is in the infrastructure, not in the software, but it's actually the core infrastructure. And it's extremely important to drive that down to bring the efficiencies there. So when we look at AI and high-performance computing, we see 3 fundamental spaces. One is, I would say, medium to large enterprises, which are setting up private systems out there for themselves. And then we see AI factories. AI factories could be AI natives, some tech titans like Meta and others, right? But could be large enterprises. And there's specialized GPU services now as the cloud providers, right? As a service provider, just for the AI market space, right? And then there's the research facilities which are also working towards that. We club all of them together into the AI factory, and the one which has a special is the true hyperscalers, right? Which is Azure's and others like that, right? Between Google and Microsoft. From the product family, right? We have a portfolio, and the way we look at it is product families have to target certain scale. When you're talking about transactions at the rate of 100 gigabytes to 1 terabyte, with a total storage less than 100 terabytes approximately, and that's what we see in the industry out there, the number of GPUs being less than 1,000. And there's a certain type of solutions we have built and shipping today in that solution space. The middle pillar is the very interesting one, and where we're seeing 1 terabytes to 50 terabytes. Again, don't just quote these numbers exact. They are ranges, they are approximations, and you're looking at petabytes to exabyte type storage. The scale, the order of scale here has been increasing order of almost 10 plus every year or 2 years in that time scale. And yes, it's going to continue to move, and we're going to watch that. Here you're looking at thousands to tens of thousands, and wherever the world takes us in the future, right? And then there are the true hyperscalers, which are looking at extremely large transaction rates from 50 plus terabytes and starting from 10 exabytes to higher. And these are the type of numbers we are looking at, and how do we solve for all of them. And I'll talk about at least 2 of them today as a solution space. On the hyperscalers, we have a direct-to-flash modules, which we are partnering with the hyperscalers to incorporate in their solution. Because they like to own everything. They don't want the full hardware from us. They want what our key IP is, and they want to build on top of that. But the scale is orders and orders of magnitude higher. Right? So we've been building purposeful solutions for each one, but under the same platform umbrella where we're taking key technologies and enabling each of these spaces. And that's the type of activities we are involved in. So as far as the portfolio, on the first pillar that you guys we saw called the enterprise, we have a product called FlashBlade S series. And the middle one is the brand new reveal we are doing. We started talking about it 3 weeks back only, and it's not shipping product at present, but we know we have a timeline in mind, which is this year, where we'll actually start going GA with this product. It's called FlashBlade Exa. Exa stands for exabyte. So it's targeting that exabyte scale and very, very, very high throughput. And the hyperscalers we are working with them on the flash module itself. Instead of SSDs, we have far more higher density, lower power footprint, and that's the value proposition we have in that direction. So just to give you a base idea, we are looking at 75 terabytes in one module, right? And it was unheard of 2 years back. But what's the underpinning, at least from the AI perspective, which is enabling all these things? And one of the key technologies out there is basically the GPU Direct, or GDS, which is basically an architecture which was pushed by NVIDIA. And the basic solution space, if you look at what NVIDIA GPUs are being targeted, whether it's AI, ML, whether it's financial industry, EDA industry, genomics, right? They are looking at very, very high compute, and they want to use the GPUs which are actually working on the different data storage elements as they have, right? So what does it really mean? So if you look at, okay, the pointer is not working. Okay, so on the left side is what happens inside the GPU, and on the green bubble is the GPU, then there's the PCI bridge and the CPU, and on the top left is the memory. Right? On the right is the storage subsystem. Normally, without the GPU Direct capabilities, everything that GPU does, going to storage to back, actually ends up going to the CPU and the memory hanging off the CPU. It adds extra latency in there. So basically, the GPUs are not able to directly talk to the flash or the NVMe or whatever the storage medium there are. What GPU Direct allows is, fundamentally, the GPU processing software can directly access the storage device without the CPU and memory involved. So it removes the CPU bottleneck, the memory bus there bottleneck, which effectively gives you a 2 to 3x of read throughput. Like I was saying, in AI workloads and AI processing, when you're actually doing training or any other activities, this is a key activity when you look at what it takes an hour to a minute sometimes. You're trying to make that type of difference as far as the time to get the results. This helps massively. So it reduces the latency and also the throughput that you can get, and removes the CPU as a bottleneck in the overall architecture. So this basic technology on Pure side, we started shipping around 2 years back, and its baseline is already there in the FlashBlade family. And as part of the recent activities in the last 1 year, we are now part of the NVIDIA ecosystem, where we got the certification as NCP certification along with that as a product. There are few players out there equivalent to us in this market. We are one of them. But it's key as a solution. If somebody is trying to set up a farm as a solution is concerned for AI, likely they will be using NVIDIA GPUs, then they'll be using storage solutions and compute solutions around that. And what's the underlying within that? People who are a little bit into the Linuxy world, and so it's built on top of standard Linux, and ROCE stands for RDMA over Converged Ethernet. Basically, you look at almost like a local DMA action, which is local memory action. It just happens to be happening on a remote server over Ethernet. So that's what Rocky enables us. So we basically use the Mellanox libraries, libIB verbs, which are now open sourced, and integrate that with our solution. And that's fundamentally how it's done out there. I won't go into other details inside that, at least for that, but just give you a little bird's eye view on what are some of the software stacks involved there. So let's get into the EXA, the FlashBlade EXA family, a product that we recently launched. I think this is the first time in India we're talking about it out here in the public. What the fundamental strengths we are looking at is we need to be able to perform at scale, and the scale can keep increasing. It's a pretty wide range. When you look at petabytes to exabytes and number of IOPS, which can go from, say, 2 tera to 10 or even high terabytes per second, right? It's in that order, and the solution should be able to keep scaling up. There should not be any fundamental limits. It should be more governed by actual hardware you can purchase, but not as a solution, right? And it should be consistent as far as write performance is concerned, and also read performance needs to be extremely high along with that. And there should be no barriers to ease of adoption. There are some similar solutions out there, but they are very, very, very high touch and stabilize and keep it functional and running. And that follows our overall model that we have built all our products to keep it really, really simple for our end customers to use. As part of the solution, it's actually an interesting disaggregated solution. And let me explain what the word metadata here is. If somebody's done an LS, you see the file owner, size, timestamp, access time, all those things. In our world, that's the metadata. And the data is what you're actually storing as the file contents are concerned, right? It could be file or it could be an S3 object. Either one doesn't matter. We support both the protocols. But what you do see in the AI world is they need to scale independently. Number of files, AI solutions tend to have a lot of very, very small files. In certain cases, in genomics, you do see certain cases, large files when you're doing image stitching, when you're trying to zoom in into DNA of each image. That sometimes does get made, but there still are lots and lots of files, right? And to be able to scale up the metadata, to go to millions and trillions and even higher number of files, and I have no limit, our base solution is called the metadata nodes, which is actually based on the FlashBlade S technology, which is extremely scalable. They're pretty much 2 raised to 64 as the number of files, and it could go even beyond if you wanted to. There are really no limits on the number of files it can have. And then when you look at the data side, what you're trying to do is use as much as possible latest hardware that you can get off the shelf. If we build our own compute cards, there is a life cycle, which typically is a 3-year life cycle. When the new processor comes in, there's always a delay when you do custom. But if you can use standard servers, you can literally upgrade them every year if you wanted to. There's always a new baby out there, new process out there every 18 months. So what we wanted to do was also scale out the data side independent of the metadata, and that's what led to this architecture, which we call disaggregated architecture. The metadata are our special custom hardware and our software, along with that, which does support a clustering of multiple nodes. But on the data side is standard servers connected over standard top-of-the-rack switches, and could be gigabytes type feeds and speeds, up to 800 gigabyte speeds and feeds. Yeah. And as tomorrow Broadcom solve that problem, we'll go even higher up there. Right? So we are looking for simplicity and agility to be able to scale up in either direction without any limits. That's the fundamental value proposition that we are trying to bring, along with our secret sauce, our overall solution, which is coming from the software side. So fundamentally, the marketing pitch here is it's all-in-one solution from training to inference to any phase of your cycle as far as the AI workflow is concerned, literally unlimitless scale, and we're following the best price performance as far as agility is concerned, as price points are concerned. But I won't go into the price point. But the ultimate performance, at least in this world you're looking at, is we measure performance in terms of rack space. If somebody's aware of what happens inside lab, a rack has 42 RUs, rack units. In one rack unit, you are looking at 3 terabytes or higher of read performance, and write performance is around to be half of that. Pretty amazing numbers if you actually talk to anybody in the industry a year back or even today, right? And that's where we're pushing really the limits, and that will increase adoption and reduce the price of actually providing AI as a service from any of the providers that you guys are looking at writing applications on top of. Yeah. So one peek, we can't show you too much in details. Our lawyers are still not allowing a lot of stuff. Patents are still being filed. But I'll show you a quick peek into the top level architecture, how we are doing this. Right? If anybody is familiar with file storage protocols, the famous one out there in the industry is NFS. And what we're trying to do on the left side are the compute clusters. This is where your storage, where your compute farms are running. This is where you're running all your training and inference, everything. This is where the GPUs are. Right? And on the right side is our solution where you talk to the metadata cores and the data nodes over Ethernet. Standard Ethernet, very high speed, over standard switches. And there's a farm of metadata nodes which will serve. And the way the client side talks is the NFS protocol. There's an enhancement in there, out there in the open source community. It's called parallel NFS. And what it allows is the client to talk to the right quote unquote data node on the bottom half we are showing, which will actually serve the data. So there are 2 architecture choices typically. One is we hide the complexity of metadata and data nodes inside our solution. But then what you end up seeing is a higher latency where your request comes in on one of the metadata nodes, and from there it is forwarded to a data node and the contents of the file are served. That increases latency. So to avoid that hop, fundamentally what we want to do is have the client directly go to the data nodes, remove all the bottlenecks in between. That's how you'll get the maximum performance you can provide. And that's what this architecture basically allows. So you can talk over NFS for metadata. You can do it over RDMA, you can do it over TCP. This diagram is right now showing TCP based, and that's pretty standard. But the data access, like I was showing the GPU direct, is over RDMA, and you can do it using standard NFS 3, v3 version, and read all the contents over RDMA. And that's fundamentally at a very high level what's going on here, right? But on the client side, you just see it as a regular file. You try to access it, it's already mounted, you access it, you get the contents. So it's very, very transparent. The way of working today from the client side, it's completely transparent. To enable that, there's a small client side patches we have to do for the PNFS piece mostly, and to be able to allow, because what's out there in the open source, there may be some issues or bugs we may find, and we will optimize those, right? So I guess this is more details behind what I already said. So there's a metadata core, which is our enterprise grade scale, which is what we have been selling, which is a FlashBlade X for now close to 8+ years. It's extremely field hardened. It's heavily deployed. You name it, any tier 1 enterprise, they're using it. So there's a lot of I would say, leg room and hardening on in there. And as far as our investment in that will continue to go on. But leveraging that as a metadata node in this solution, it has full automation observability built in. If you look at from the actual provider perspective, and they're looking for visibility into what's going on inside the box. And the data nodes are the off-the-shelf solutions, which are using standard SSDs. We may change and evolve that going forward, but that's what we have today, right? And that's what's built on today. So you can have to do 100 gigabits per node on the data node. As the world moves forward from that, whether it's Intel or anybody else, I know there are a lot of Intel folks here. So if you guys push it to 400, we'll go there, right? And that's where we want to go. And that's where our overall scale-out architecture is based on. Okay, and here's a slight peek into what's the software stacks inside the data node. It's RDMA, like the GPU direct picture I was showing you. There's an NFS server subsystem, there's a file system, which is XFS, and then RAID, and then the actual volume management of the SSDs, right? It provides reliability as part of that overall solution, right? It's optimized heavily for networking. We're using the NVIDIA CX8 NICs and support those, at least on all the RDMA support we need on our side. Right? And it's definitely getting tuned. You won't get the performance without tuning it. So we are doing the tuning on our side, on what you get from standard Linux on top of that. That's at least, and then the control part. And what's happening in the metadata node, the key technology we have in there is we have a distributed transactional database inside our solution. Like if you heard about Oracle and all those databases, fundamentally, believe it or not, a storage system internally has a database. A file system is actually nothing but an amazingly clustered parallel database engine. Yes, we have the business logic for the file I/O part, but the key piece is actually that distributed database where to be able to do end transaction all in parallel as much as possible, lockless design, and that's what gets you the throughput. And we call it a key value store. It's heavily distributed, it's transactional. Once we say a commit, you cannot lose it. It's somebody's data, we cannot lose a single bit. Yeah. But that's an art we have perfected over the years. Along with that, we have some log structured information which we are storing finally in the persistent store. And then we have a key technology which is called direct to flash. If somebody's aware of the flash technology, there are only so many writes you can do. And how do you take a low-end flash like QLC and actually get it to a enterprise-grade solution is one of our secret sauce in our software. And we call it direct to flash module. And that's where we play some of our magic in. And those are one of the big innovations we constantly go invest in. But these are I would say, the key pieces inside the FlashBlade core, our operating system that we have on our solution. Hopefully that gives you an insight into what's going on. And this is a high-level picture on how we're scaling. There's a 800 gigabits links from the top of rack switches all the way to each of the FlashBlade chassis. And internally, we do have a fabric module where we distribute all the traffic in all the blades inside the FlashBlade. There are 10 blades per chassis, so it has a load distribution in there using ECMP type logic. That's what's going on inside the system, at least on the metadata node, and how it is scaling up. It's all based on VIPs and virtual IPs and how the traffic comes in. We export a bunch of data whips, and that's how the load balancing happens inside our cluster. Okay. And that's about it from my side. We do have other folks and representations talking about how we're actually using AI in our solution. To keep a watch out for those. There we're actually applying the AI technology that we're building for our end customers as a further value add. Okay, but this one was more to give you a high-level picture.